Okay, here's the scenario. You're stuck on a desert island pumped full of electromagnetic energy. You have some Pisum Sativum plants you like to grow, but will the magnetic field accelerate growth or hinder it? Hi, I'm Ryan Brockington, and today I'm going to show you how to survive. Most of my sources claim that germination was generally accelerated by higher than normal magnetic fields. You see, Earth has its own magnetic field called the geomagnetic field. Wow! But when you take out that metal radioactive drama case, your phone, you send out electromagnetic frequencies. With this happening all over the world, the frequencies of electromagnetic activity increase, along with radio towers, electromagnets, and much more cool stuff. But is it killing or hurting plants? Or hindering germination? We all know that we've done stuff that have hurt plants before, not to mention the stuff you generally do that you're not supposed to.
Oh my Neptune, he's mixing garbage and recycling!
But using your phones? Does that hurt? I don't know, I said. I believe that if one generates a constant electromagnetic field of a higher frequency, it will greatly accelerate germination, I said. So I took a pipe. I wrapped a wire around this pipe many times. How many? I don't know. I didn't count. And then I put the pipe in a pot. Then I put soil in the pot with the pipe. And then I took the pipe out, and I put 8 pea seeds in the soil, in the pot. Yes, the seeds were in the pot, in the soil. Then I put the pipe back on. And you can probably guess what I did next. You guessed it. I hooked each end of the wire to a DC regulated power supply that pumped about 7 volts into the wire. But this wire wasn't just any wire. It was magnetic wire. So guess what? It's an electromagnet. Not quite. I was just generating an electromagnetic field. What about the control? Oh yeah. Now I said, fun joke. Let's see how long it will take for these seeds to germinate. They didn't germinate. At least that's what I said on Friday. Great, now let's do some chi-squared. The expected value? Whatever it says on those seed packets. Oh, it says 7 to 14 days? We'll take the mean of that. 10.5 days. When did our seeds germinate? They didn't. What now? Well, obviously they're still taking their time, or you happen to kill them. Fast forward! Nope. Oh my gosh. They germinated. Oh my. Well, this is nice. Oh yes, look at this green little plant right here. Oh yes. Oh yes. This is good. This is good stuff. So the control seeds germinated. At least 5 of the 7 I found did. The last one, presumably did. Thus, the germination rate of the control was 63%. If I were to wait longer, it would most likely be higher. On the other hand, the variable seeds looked pathetic. Only 4 were found. Trust me, I sifted through dirt to find the rest. The others most likely rotted and disintegrated. Don't ask me why, I don't know. Just kidding, I have a theory. In other experiments, the electromagnetic field was only turned on for specific periods of time. In mine, it was on constantly. So that probably did something. You know what all this data allows me to do? Finish the chi-square. Null hypothesis. All the pea plants will germinate within 10.5 days, and if there's any variation, it's due to chance. It took 7 days for the control seeds to germinate. The variable seeds did not germinate, thus they are 0. The degrees of freedom is just 1. P equals 0.05 in this one. After all the calculations, the value comes out to be 11.67. The p-value in the degree of freedom 1 range is 3.84, so the null hypothesis is completely rejected. Thanks, variable seeds, for screwing everything up. Congratulations. Your real hypothesis still failed. Here's a data table. Here's a graph. The data table shows when the seeds actually germinated. The graph shows germination rates. Notice how it's 0% for the variable. In all, the pea plants in the higher electromagnetic field obviously did not germinate significantly faster than the ones in the control. Thus, I flushed my hypothesis down the drain. I mean, in all honesty, I don't think I generated enough electromagnetic power compared to some of these other professional experiments, and that could be a reason why I had to shut down my hypothesis. I generated about 0.3075 milliteslas above the regular geomagnetic strength. compared to the 120 in other experiments. That's, weak. Though, you're kind of limited in what you can do inside of a high school. It's not like you can bring in a $46,000 GTM cell and power wash your plants with electromagnetic activity.
Hey Mom, where's your wallet?
Error time! How many errors can you find in this experiment? Well, one side of the wall blew a fuse, so I had to move the experiment to the other side of the wall. So that could have hindered some stuff. Maybe if I didn't try to grow a plant that grows in an average of 10.5 days in 7, things might have gone more smoothly. I could only get one power supply. Thus, I only had one variable and one control. You'd need more if you wanted more accurate results. I think that water and light consumption was off and not consistent as it should have been. All these things could be confirmed as errors that could have possibly thrown off experiment data.
As a follow-up, I'd like to do the same exact experiment, but instead of with germinating plants, with stem cells. You see, there's research that shows when you electromagnetically shock stem cells, it gets them to differentiate more than they generally would. So that is something I'd want to do in the future.